Hey guys, so this is our first ACT science video, and let's just go ahead and get started. Flood basalt plateaus are large areas of Earth's surface covered with thick hardened lava. It has been hypothesized that the huge outpourings of lava that formed these plateaus were produced by plumes of molten material rising from deep within Earth. A model of a typical plume was created using a computer. It was hypothesized that the head of the plume produced the flood basalt plateaus when its molten material reached the surface. Figure 1 shows a computer-generated plume, its diameter, and how long in millions of years it would take the head of the plume to reach the surface. So here we have the head, elevation, 0, time to reach the surface, and the direction of movement. Okay, so study 2. 4 flood basalt plateaus were studied. The lava volume in cubic kilometers was estimated for each plateau from the area of the plateau and the average thickness of the lava, the length of the time lava was being produced at each plateau, and the rate of lava production in kilometers cubed per year were also estimated. The results are in Table 1. So Table 1, Plateau A, age is 60 million years, lava volume 2 million kilometers cubed, length of time lava was produced 1.6 million years, rate of lava production is 1.25 kilometers cubed per year. B, 67 million years, that's the age, 1,500,000 kilometers cubed lava volume, 1.3 million years for length of time the lava was produced, and the rate of lava production is 1.2 kilometers cubed per year. And there are similar values for C, D, C and D. Okay. Study 3. Scientists found that 3 large extinctions of marine organisms had ages similar to those of the formation of 3 of the flood basalt plateaus. 58 million years, 66 million years, and 133 million years. It was hypothesized that the production of large amounts of lava and gases in the formation of plateaus may have contributed to those extinctions. If the plume model in Study 1 is typical of all plumes, the scientists would generalize that the heads of the plumes are. Let's snip this for a second. Okay, if the plume model in Study 1 is typical of all mantle plumes, the scientists would generalize that the heads of the plumes are. A model of a typical plume is created. It was hypothesized the head of the plume produced the flood basalt plateaus when its molten material reached the surface. Figure 1 shows a computer-generated plume, its diameter, and how long in millions of years it would take the head of the plume to reach the surface. So let's look at the answer choices for this question. If the plume model in Study 1 is typical of all mantle plumes, the scientists would generalize that the heads of the plumes are approximately half the diameter of the tail, approximately twice the diameter of the tail, the same diameter as the tail, or half as dense as the tail. Okay. So as you can see, diameter is this way. So we can tell that it's not half the diameter of the tail, because the head has a larger diameter than the tail. So we can X that out. A is out. B, approximately twice the diameter of the tail. That seems like a possibility, but we don't want to put that in yet. Let's see. Let's just look at it. This goes from about 0 to, let's say, 200 or something, and the head goes from 0 to like 400. So yeah, approximately twice the diameter of the tail is a possibility. We're going to put a question mark on this one. The same diameter as the tail, we know right off the back that's false. Half as dense as the tail. Remember, density is mass divided by volume. So, does density even have anything to do with this? I mean, it's not even in study 1, right? Density comes later on in a different study, so the correct answer should be B. Let's just check our answer just to make sure. Yes, the correct answer is B. Okay, let's move on to our second question. Get this out of the way. The scientists in Study 3 hypothesized that the larger the volume of lava produced, the larger the number of marine organisms that would become extinct. If this hypothesis is correct, the formation of which of the following plateaus caused the largest number of marine organisms to become extinct? So the first thing we do is we go back to Study 3. In Study 3, scientists found that 3 large extinctions of marine organisms had ages similar to those of the formation of 3 of the flood basalt plateaus, 58, 66, and 133 million years respectively. It was hypothesized that the production of large amounts of lava and gases in the formation of plateaus may have contributed to those extinctions. Okay, so in problem 2, what it says here, the scientists in Study 3 hypothesized that the larger volume of lava produced, the larger the number of marine organisms that would become extinct. If this hypothesis is correct, the formation of which of the following plateaus caused the largest number of marine organisms to become extinct? Well, you're going to have to go back to look at Study 2 for this one at the same time. 4 flood basalt plateaus, A through D, were studied. The lava volume in cubic kilometers was estimated for each plateau from the area of the plateau and the average thickness of the lava. The length of time lava was being produced at each plateau and the rate of lava production in kilometers cubed per year were also estimated. The results are in Table 1. Okay. So the hypothesis was that a larger volume of lava produced, the larger the marine organisms that would become extinct. So which of the following plateaus through this hypothesis caused the largest number of marine organisms to become extinct? All we got to do is look for the largest lava volume. So if I get my magnifier back on, as you can see, Plateau A has 2 million kilometers cubed. Plateau B has 1,500,000 kilometers cubed. Plateau C has 1,440,000 kilometers cubed, and Plateau D has 2,125,000 kilometers cubed. Since the lava volume is largest at D, the answer is J, Plateau D. Okay. Based on the results of Study 2, a flood basalt plateau that produced lava for a period of 1.8 million years would most likely have a lava volume. Okay. So let's just snip that. And by the way, during the test, it's not going to be this slow. I just like to go a little slow so everyone understands and can keep up with my pace. Okay. Based on the results of Study 2, a flood basalt plateau that produced lava for a period of 1.8 million years would most likely have a lava volume. So the results of Study 2, 4 flood-based plateaus were studied. The lava volume in cubic kilometers was estimated for each plateau from the area of the plateau that and the average thickness of lava. The length of time lava was being produced at each plateau and the rate of production in kilometers cubed per year were also estimated. The results are in Table 1. And so if we go back to our question, so we really have to look at the data for this. Age of produced for a period of 1.8 million years. So as you can see over here, we have 1.6, 1.3, 1.2, and 1.7 length of time that lava was produced. And it's asking us to make an inference about the lava volume. So as you can see, the lava volume increases as the length of time lava was produced increases. So if we had 1.8 million years, it would be greater than this greatest value, 2,125,000. It would be over 2,125,000 kilometers cubed. Okay. I could just find my pointer. Hey, I can close Windows Journal now. According to Study 2, which of the following statements best describes the relationship, if any, between the age of a flood basalt plateau and the length of time lava was produced at that plateau? So the age of the flood basalt plateau and the length of time the lava was produced at that plateau. Age and length of time lava was produced. So what is the correlation between the age and the length of time lava was produced? Is the age, is the length of time the lava was produced in millions of years? So here we have age 60. Length of time lava was produced is 1.6 million years. Age 67, 1.3 million years. Age 135, 1.2 million years. And age 192, 1.7 million years. I'm not really seeing a pattern over here. It kind of increases and decreases. But let's see what our answer choices are. If I go back here. According to study 2, which of the following statements best describes the relationship, if any, between the age of flood basalt plateau and the length of time that the lava was produced? As the age of a plateau increases, the length of time lava was produced increases? No, because we just saw a random decrease and then a random increase. When the age increased, there was one random decrease and one random increase in the length of time that lava was produced, so that can't be the answer. As the age of the plateau increases, the length of time lava was produced decreases. That can't be the answer either, for the reason I just stated. As the age of the plateau increases, the length of time lava was produced increases. And then decreases? Well, as you can see, as age increases, it actually decreases first, and then it increases, so that can't be the answer. So the correct answer that we're left with is J. Okay, so the answer is J. Let's take a look at that. Let's move on to our next problem. I might have to snip this one this way. I'm going to need Windows Journal for this one. Which of the following graphs best represents the relationship between the age of a flood basalt plateau and the rate of lava production? So remember, the rate of lava production is in kilometers cubed per year, and the age of the plateau is in millions of years. Age of plateau is on the x-axis. Okay, so which of the following graphs best represents the relationship between the age of the flood basalt plateau and the rate of lava production? Age and rate of lava production. Well, if you look at this over here, as the age increases, 60, 67, 135 to 192, rate of lava production decreases and then increases again. So that's kind of like goes down, remains flat, and then increases again, because this 1.2 and 1.2, they stay the same. Goes down, remain flat, and then increases again. The only thing that actually matches this, but we want to make sure that the amounts are right. So I believe that the answer is either B or C, but let's try to figure out which one of them it is. So rate of lava, length of the rate of lava production decreases, increases again. And it goes from 1.25 to 1.2 to 1.25 all over again. So it can't be C. This has to be B. The answer is B. So where is our Windows Journal thing? The answer is B, because it starts at 1.25, decreases stays flat for a while at 1.2, and then increases again for the rate of lava production, kilometers cubed per year. Okay. Alright, so that's good. And then if the hypothesis made by the scientists in study 3 is correct, evidence would most likely be found of another extinction of a marine organism that occurred around. Okay, let's go back to study 3. Scientists found that 3 large extinctions of marine organisms at ages similar to those of the formation of 3 of the flood basalt plateaus, 58 million years, 66 million years, and 133 million years. It was hypothesized that the production of large amounts of lava and gases in the formation of plateaus may have contributed to all those extinctions. So if the hypothesis made by the scientists in study 3, which is that the production of large amounts of lava and gases in the formation of plateaus may have contributed to those extinctions, if this hypothesis is correct, evidence would most likely be found of another extinction of marine organisms that occurred around. Well, during what period of time was there large amounts of lava and gas? We have to look back over here. As you can see, the greatest lava volume is at 192 million years. I want to say that the answer is G, but let's check it. I, again, am not perfect. If you saw my math videos, I made a couple of mistakes, silly mistakes. So, yeah, it's important that we check our answers occasionally if we don't understand or if we're confused. Science. Number 6 is G. So, wait. Are we doing number 6? Yeah, number 6 is G. I was correct. So, again, why was I correct? Because G, we're given 192 million years, and this has the greatest lava volume. So, the hypothesis over here is that large amounts of lava and gases in the formation of plateaus may have contributed to all those extinctions. Since this has the largest lava volume, this is a large amount of lava that was produced, and hence the age is 192, and the answer is plateau D. Okay, so I hope you enjoyed that video, and please subscribe and come back for my next one.